Hello guys, welcome to another tuition from Steven from differentiation from first principles. So we are going to solve these questions as we couldn't do in the first video. So here are the questions, a common preamble to the four questions, and I'm to solve two, leaving two for you as an assignment. So let's begin. These are the two that I'll solve, this one and the first one, and you take this and that as an assignment to do to also know whether you've grasped the concept or not. So now let's begin. Um, they are restricting us to use the first principles, so you can't go straight to differentiate using the differential notation. That one you'll be marked wrong. So let's move on. So knowing the first principle already, in solving questions like this, um, firstly you have to code the first principle down, the formula down. You have to put it down. So it says that what the first differential f prime of x is equals to lim as h approaches 0 of the expression f of x plus h minus f of x, that expression all over h. Have you seen the first principles? So now what we will do is that, which function did they give us to differentiate with the first principle? So I'm solving this. Look at it, this. So you say given f of x to be equal to square root of x squared plus 1, square root of x squared plus 1, that's your f of x. Then we'll have it here, I won't quote it down again. Then we'll say f of the expression x plus h will be equals to what? Because you are finding all this separately, I don't want to substitute everything there, whereby we'll make a mistake by our eyes skipping something else. That will lead us to a wrong answer. So finding f of the expression x plus h will give us anything anywhere you see x, you put x plus h there. So you get square root of x plus h in bracket square, that one is under the root, plus 1 also under the root. So have you seen that, guys? Now we move on by finding this operation, that is subtracting f of x from f of the expression x plus h. So in doing so, we will get f of x plus h minus, that is f of the expression x plus h minus f of x, to be equal to square root of into bracket x plus h all squared plus 1. This expression is under the square root, then plus another term, that is another square root. Under the square root we will have x squared plus 1. So this is f of the expression x plus h minus f of x. So guys, we'll move on. So when we move on, we will now put everything, this particular operation, into the gradient function, or the first differential, or let's say the first principle, so equation. So in putting it in there, we will get f prime of x is equals to lim as h approaches 0, of square root of, in under the bracket, x plus h in bracket all squared, under the square root rather, plus 1. So plus another square root, then we'll have x squared plus 1 there, then that one bracket close all over h. So guys, note that if you substitute your 0, if you are finding limits, you always, after manipulating with the function to get a suitable one, substitute your 0 there. But note that per the knowledge you have and limits, if you substitute your 0 here, get something like undefined, that is in your syllabus. But here we say infinity, and it depends on the sign that is attached to the particular quotient you are finding. If it is a negative sign, you say negative infinity. Then a positive sign, you say infinity. So guys, our aim here is to do away with getting 0 at the denominator. But there are some stubborn functions that no matter what you do to them, you will never get a 0. You will never get a suitable function whereby you will not get something like undefined. You will continue to get undefined. But in this case, it is not so. So let's move on. Guys, in moving on, what we will do is that you have to take a look at it, how to go about the manipulation, whereby you will not change anything. That is one. Two, whereby you get a suitable function. That is another. So you have to think here critically. That is, you have to be initiative in thinking. So guys, so in manipulating this, we realize that the numerator consists of let's say a radical function, because all these expressions are having radicals, so they are radicals. So that's a radical expression rather. So that the numerator consists of radical expressions, the sum of two radical expressions. So what we will do is that based on our knowledge on conjugates of a this thing in conjugate of SAS, we use that one here in order to get a suitable um, um, expression or function, gradient function, in order to substitute our 0 there. So let's move on, guys. So now, what will we do is that we will simply say this is equal to, then we'll bring our bracket, then I hope you know how to find the conjugate of this already. So we'll bring our bracket, then we'll have square root of into bracket x plus h squared, then we'll have plus 1, then plus another square root of x squared plus 1. Sorry, it was minus, sorry, it was minus. So minus this, it was minus. So minus square root of x squared plus 1. Then we'll have that one in bracket multiplying by its conjugate. So square root of to bracket x plus h squared plus 1 plus square root of x squared plus 1, then bracket close. Guys, have you seen that? Then we'll close the bracket. All over h multiplying by the conjugate of this one, square root of bracket open x plus h squared plus 1 plus square root of x squared plus 1. Have you seen that, guys? So now, moving forward, realize that multiplying any a rational, sorry, any radical function by, or any radical expression rather, by its conjugate will give you something like difference of two squares expression. So looking at this, we realize that it is a difference of two squares, but you always have to remember to bring the lim as each approaches 0. So this will be equal to that. So guys, that is what we do. Now moving forward, we'll have this one as difference of two squares, so have it as lim as h approaches 0 of the whole of this. So this multiplying by this, what will we get, guys? Get something like the square roots will go off, so we'll get something like square bracket open, another bracket open, x plus h bracket close squared. So have you seen that, guys? Plus 1, then the square bracket close, then minus bracket open x squared plus 1. Have you seen that, guys? Bracket close, then you bring one another bracket here, then all over h multiplying by square root of the expression x plus h squared under the square root plus 1 plus square root of x squared plus 1. So guys, this is how we go about the manipulation, our simplification. So moving forward, we'll have to expand this one in order to do away with certain common terms here. So let's move on. So moving on, we'll have, opening the bracket, we'll have lim as h approaches 0, have it to be equal to that, then the bracket open, then opening the bracket, we'll have x squared plus 2xh 2xh plus h squared plus the 1, and this minus, we are opening that bracket too. So we'll have x squared minus 1. Have you seen that, guys? So this will be all over h multiplying by square root of x squared plus 1, then that one plus square root of into bracket x plus h all squared plus 1. These are under the square root, and then someone will say I've interchanged them, and addition is commutative. That is why you can leave them that way. So moving forward, this one will go away with this one, and then the 1 2 will go away with the 1. So after they've all left with these particular terms, you will notice that there is a common variable here and here. So factoring that one out, we'll have it as lim as h approaches 0 of h multiplying by 2x plus h bracket close, then all over, have you seen that, guys? H multiplying by the expression square root of x squared plus 1, then that square root plus another one, that is under it, x plus h in bracket squared plus 1, then you close your bracket. So the h is multiplying by all this. So guys, have you seen that? Then we realize that here there is h there, and then here there is another h there, and normally it is always because of this h that we always get undefined, normally, like usually, but not always. And so we quickly do away with both h, and then after doing away with them, we are now allowed, or can now see that 0 can be plugged in. So plugging in 0 gives us 2x plus 0 all over bracket open square root of x squared plus 1, then plus square root of x plus 0 squared plus 1 under the square root. So this will further give us 2x all over square root of x squared plus 1 plus square root of x squared plus 1 under the root. So now we realize that these are common. These terms are common, so we add them. So guys, we'll further get 2x all over 2 root of x squared plus 1. Now we'll notice that there is 2 here at the numerator. There is 2 also here at the denominator. So what we'll do is that we quickly do away with those 2's too. Then we will now get x all over square root of x squared plus 1. So that is our first differential from first principles. So this is our answer, guys. So if you don't get this, you are wrong. And I hope you followed me well to get the procedures and everything. So guys, let's look at the next one that I said I'll be solving. And then that one is more or less like the reciprocal of the first one. That one too isn't easy. It is easy, rather. It is easy, but if you are not more careful, you might make mistakes alongside. So guys, let's solve that one. So firstly, what you will do is that you first say, given the function f of x is a radical function, even a reciprocal, let's say a radical rational function, because it is a quotient, and then a quotient of this thing, two functions, and also has a radical sign. So 1 over square root of x squared plus 1. So this is the function that we are going to differentiate using the first principle. So guys, what we will do is that we put down our first principle equation, that is f prime of x is equal to limit as h approaches 0 of the whole of this expression, that is f of the expression x plus h bracket close, then that one minus f of x all over h, then bracket close. So have you seen that? Then our aim here now is to get f of x, which is the original function, and then get f of x plus h as well. Then we do the necessary operations. So guys, moving forward, we'll say f of x, that is this one, is equal to 1 over square root of x squared plus 1. Have you seen that, guys? So this is wonderful. Then we will have f of the expression x plus h to be equal to 1 over, wherever you see x, you put x plus h there. So square root of bracket open x plus h squared plus 1. These are all under the root or the radical sign. So moving forward, guys, what we will do is that we quickly find f of the expression x plus h minus f of x, which will be equal to 1 over square root of x plus h in bracket all squared plus 1. These are under the root, minus 1 over square root of x squared plus 1 under the root. So in simplifying this, guys, we will get square root of x squared plus 1 minus square root of x plus h all squared, that is the numerator, plus 1 all over the denominator, and that will be square root of x plus h in bracket squared. Have you seen that, guys? Plus 1 plus 1. So that one multiplying by square root of x squared plus 1. So have you seen that, guys? That will be how we will go about it. So after getting our f of the expression x plus h minus f of x, we simply put it into the first differential, that is the first principles equation. So in doing so, we will now have our equation containing the expressions as f prime of x to be equals to lim as h approaches 0 of the whole of this. That is introducing a bracket to show you the numerator and the denominator. So I'm introducing another bracket. So we have square root of x squared plus 1 minus square root of to bracket x plus h in bracket squared plus 1 all over square root of x plus h in bracket squared plus 1 and multiplying by square root of square root of x squared plus 1. So that is it, guys. So this particular numerator is also a rational. So all over h, this h will also be over 1. So guys, have you seen that? So now let's continue. So in continuing, what will we get? Guys, in dividing a fraction or a rational by another one, see that this one will take the reciprocal of the denominator rational, that is this one, and multiply by the numerator. So in doing so, let's assume we've done so. So in doing so, we'll now have f prime of x to be equals to lim as h approaches 0 of the whole of this square root of x squared plus 1 and minus square root of into bracket x plus h all squared plus 1. Then that will be all over h multiplying by square root of x plus h, that will be squared plus 1 under the bracket multiplying by square root of x squared plus 1. So bracket close. That is it, guys. So this is what we will get. Noticing that when we substitute h at this instant, we will get 0 at the denominator because 0 substituted here will be multiplying by all this, which will give us 0. So we will have to do away with that h, which is the main obstacle giving us an undefined expression. So how are we going to do away with that? We simply look at both the numerator and the denominator to find out which one can we find the conjugate and then multiply. See that the denominator is multiplication of two radicals and the numerator is subtraction of two radicals. So conjugate is always associated with addition or subtraction of radical functions or numbers and co. So what we will do is that we quickly find the conjugate of this one and multiply by both the numerator and the denominator. I'm sorry that I couldn't explain to you at the first part why we are doing so and why we always multiply it by. I explained to you why we are doing so, but I didn't tell you why we multiply by the numerator and the denominator. We do so because in doing so, you will not change anything in the function. That is, when you take the conjugate at the numerator over the conjugate at the denominator, you will still get 1. And then 1 times the whole expression will still be the same. That means that we've done nothing to the expression, but we are just manipulating it to get a suitable one. So moving forward, we'll have that to be equal to lem as h approaches 0 of into bracket square root of x squared plus 1 minus square root of into bracket x plus h squared plus 1 under the square root rather, then bracket close, multiplying by another bracket, that's the conjugate. We'll have it as square root of x squared plus 1, then the conjugate of this will be plus square root of into bracket x plus h squared plus 1, then close the bracket, that one all over each multiplying by the same, each multiplying by this, multiplying by the same conjugate. So multiplying by this, we will have it as bracket open x plus h squared under the bracket plus under the square root rather plus 1, then bracket close, multiplying by another radical square root of x squared plus 1, bracket close, multiplying by the conjugate now, square root of x squared plus 1, then plus another expression, bracket open, square root under the square root, bracket open, x plus h squared plus 1, then you close the bracket and then close the final bracket. So guys, this is how we do it. Now noticing that this particular expression is difference of two squares, denotes difference of two squares, we don't have to worry ourselves opening it to get a cumbersome expression, an expression that will be cumbersome rather to deal with. So what we'll do is that we quickly apply that knowledge there. And then here, we'll notice that this one is a single term since they are multiplying by one another. It's a single term, these three terms. So multiply each, we'll multiply it each by this. We will multiply this each rather by that single term. So in multiplying this by this, the square root will go with this one. It will go because it will be like squared. And then this squared will go with that, leaving only this expression. That way that this one too will go, leaving the expression here alone. So guys, let's see what I'm talking about. So moving forward, we will have the expression to be equal to lem as h approaches 0 of, told you apply difference of two squares. In applying that, guys, you get x squared plus 1 this way, x squared plus 1, then minus x square bracket open x plus h all squared plus 1 square bracket close. This will be all over h multiplying by x squared plus 1 bracket close, multiplying by bracket open x plus h all squared plus 1. This is under the square root, then plus another expression, that is h multiplying by x plus h, that's square bracket open, another bracket open, x plus h all squared plus 1, then we'll have square bracket close, then we'll have it multiplying by square root of x squared plus 1. So this bracket close, and then finally close the bracket. So guys, moving forward, we will have to expand this one. After expanding that one, then we'll do our necessary operations here. Mass operation there. So we'll have it as lim as h approaches 0 of, then we'll have x squared plus 1 minus this. So we'll have to expand this one. We'll have x squared plus 2xh. I hope you know expansion already, how to expand binomials, trinomials, and onwards. So I don't want to waste time. I don't want the video to get to an hour. So half plus h squared plus 1 bracket close. So this will be all over, that's the denominator, h bracket open x squared plus 1 multiplying by another expression, square root of, under the square root we'll have x plus h all squared plus 1, then we'll have bracket close, then plus another expression again, h rather, multiplying by square bracket, another bracket open, x plus h all squared plus 1 square bracket close, then we'll have it multiplying by another expression, square root of x squared plus 1, then bracket close, then we'll close the whole bracket. Now guys, we'll notice that when we do the subtraction, this opening this bracket, we will have negative attached to every term inside this bracket. So this will go away with this, and the 1 will also go away with this. So guys, if this goes away with this and that too goes away with that, then we'll have these two terms left. So these two terms left too are having h. Have you noticed that? So we can quickly factorize h there. I don't want the steps to be more in such a way that the video will be long. No. So when we factorize the h out, guys, what will we get now? So we'll have it as lim as h approaches 0. We can also factorize the h here and then h here too. Have you seen that? We can factorize them two out. So we'll have as h approaches 0 of h factoring h out or getting h out, then bracket open 2x plus h, then bracket close. This will be all over h2 out here. Then we'll have x squared plus 1, then bracket close, then bracket open, square root of, bracket open, x plus h squared plus 1 under the bracket, then we'll have bracket close. This one is a square bracket, let's put it that way. Then we'll have plus another expression, some small square bracket, bracket open, x plus h bracket close square plus 1. This one, the square bracket close. Then multiplying by another expression, square root of x squared plus 1. Then we close our bracket. Now guys, we can do away with this 2h. So this h will go away with that. So realizing that what will make our expression undefined is gone, and we can quickly substitute 0 there. So in substituting 0 there, guys, what will we get? So we'll get lim as h approaches 0 off. Then you substitute 0 there. Sorry, when we are substituting 0 there, you don't bring this one again. Sorry. So in substituting the 0 there, we'll have 2x plus 0 and all over. Then we have bracket open, x squared plus 1 multiplying by another expression, square root of, bracket open, x plus 0 squared plus 1. These are under the root, and then that's bracket close 2. That's bracket close 2. Then plus another expression, square bracket open, another bracket open, x plus 0 squared plus 1 bracket close, square bracket close. Then we'll have another bracket open, square root of x squared plus 1 bracket close. This is how we do. So guys, we'll get something like this. 2x all over, this will be x squared plus 1 multiplying by square root of, this will be x squared plus 1, then plus another one, x squared plus 1 multiplying by square root of x squared plus 1. So guys, noticing that these ones are the same, we can add them. They are the same expressions, so we can add them. We will have 2x all over, then we'll have 2 multiplying by x squared plus 1 multiplying by square root of x squared plus 1. Have you seen that, guys? So now what we will do is that we'll do away with this particular 2 and that one. Then our final answer will be x all over, bracket open, x squared plus 1 and multiplying by square root of x squared plus 1. Have you seen that, guys? So this is our final answer. So if you differentiate that function without getting this answer, meaning you are wrong, guys. So this is our final answer. I encourage you to solve more and more questions and solve this particular question too as well that I gave you, guys. Solve this one too. Where is it? Solve this particular questions. I gave you this as an assignment, and that too as an assignment. So guys, don't forget to like and subscribe. Also share with your loved ones and even with your enemies. God said, love your neighbor as yourself. Do so. And also comment so that I bring to you the best videos of mine. Thank you.